Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे हमें बैंड गैप कंडक्टर सेमीकंडक्टर आउ इन्सुलेटर विषय रे पढ़िबा ऑलरेडी तमे या विषय रे प्लस 2 आउ प्लस 3 रे भी इलेक्ट्रॉनिक्स रे पढ़िचो सो जनरली हमें गोटे सॉलिड को तीनटा कैटेगरी रे डिवाइड करि परिबा कंडक्टर insulator आउ semiconductor depending upon the band gap. So band gap means it is the gap between the valence band and conduction band. So let us calculate the effective number of electrons, which are obviously the free electrons in a band, so as to differentiate between the conductors, insulators and semiconductor on the basis of band gap. Remember এই তিনটা ক্যাটাগরি को डिसाइड करे এই जो फ्री इलेक्ट्रॉन्स केते संख्यक अछि ओके सो वी नो दैट the electron in the k state is actually bounded to a lattice and therefore the effective mass of the electron is different from the free electron mass. So let us now consider an empty band which is filled with the electrons up to the wave vector k1 as you can see in the figure a bhaliya yaro shape ta ba plot ta asila such that this k1 is less than pi by a and it is within the first Brillouin zone, that is from minus pi by a to plus pi by a. Now the ratio of the free electron mass to its effective mass in the k state can be taken as the extent to which the electron in that k state is free to take part in the conduction purpose. That means mathematically a ratio को यदि हमें लिखिला to be equal to fk, that is equal to m by m effective, then it is equal to a effective mass ର value टाको हमें put कर देला. Now in one dimensional lattice jar length जदि हेगला capital L, then the number of states in the interval dk is given by dn equal to L by 2 pi into dk. Therefore effective number of electrons in the interval dk ये हिजबो dn effective into that is equal to 2fk L by 2 pi dk. So देखो एठी गोटे additional factor आछि 2 okay which is obviously due to the Pauli's exclusion principle according to which each state will be filled by 2 electrons. Already या विषय रे प्लस 2 रे भी तमे पढिछो ताले एबे जदि हमें ए dn effective या को जदि इंटीग्रेट करिबा we will get the total number of effective electrons if the band gap is filled up to k1 okay. So n effective, that is the total number, will be equal to 2 constant बाहर को आसीगला. This will be the integration और यार वैल्यू टा आसीबो 2lm by pi h cross square into de by dk at k equal to k1. Hence the effective number of electrons available for conduction depends upon the factor, that is de by dk. Okay, now coming to the band gap, which is the difference between the highest value of energy in a given band and the lowest value of energy in the very next band above it. Okay, so generally हमें याको कहबा conduction band आउ valence band जो भितरे difference बा gap टा अछि, that is the band gap, and these band gaps are also called as the forbidden energy states or simply forbidden gap. Now the allowed energy bands in a solid at suppose lowest temperature हमें कही देला, that is 0 Kelvin. Okay, so the lowest energy are filled with the available electrons from the bottom upwards. Okay, तळरू ऊपर आडकू इलेक्ट्रॉन हिसाब रे ये सजेइकी रहिबो as per the Pauli's exclusion principle till all the electrons are accommodated. Okay, now with the increase of temperature jete jete ame temperature ku बढ़ेइबा the electrons in the valence band shift to still the higher empty levels in the conduction band. Okay, so the application of ଯେତେବେଳେ ଆମେ କିଛି ବାହାରୁ field ପକେଇବା externally influence କରିବା, suppose electric field ପକେଇଲା କିମ୍ବା magnetic field ପକେଇଲା, also it will compel the electrons. Okay, ଗୋଟେ ତ ଦେଖିଲା ଆମେ increase କରୁଛୁ ଯଦି temperature ଦ୍ୱାରା, besides that electric field ହେଲା, magnetic field ହେଲା, they will also compel the electrons to cross over that band gap and shift towards the conduction band. Okay, all solids however do not behave alike. Okay, this is a very important point. So some solids are classified into conductors, some into insulators, and the rest are referred as the semiconductors. Okay, so for a completely filled band, suppose for example at the first Brillouin zone the boundaries which is k equal to plus or minus pi by a एटा हमें जानिछु. So the slope of the curve जोटा कि हमें first figure रे देखिला will be 0. Okay, now as the graph is flat at the top, that means dE by dk जो factor ऊपर depend करथिला this will be 0 or effective number of electrons is 0. That means the number of free electrons in a completely filled band is 0. Okay, तामाने गुटे जदि बैंड completely fill up ହେଇଯାଉଛି କିଛି ବି ଆଉ free electron ମିଳୁନି for conduction purpose. That means the point at which the band is filled up to k equal to k0 is called the inflection point, and at this point the effective number of electrons becomes maximum. Okay, a point here to remember, an inflection point here, the nature of the slope in the graph between E and K changes sign from positive to negative. Okay, एबे आसीबा classification को. First आमे देखिबा insulator. Okay, insulator here the valence band is full while the conduction band is empty. Okay, and they have large energy gap between the valence and conduction band which is of the order of 5 to 15 electron volt. Okay, and this energy band diagram you can see in the figure, and they do not have any free electrons. Okay, you can see this is the energy gap or forbidden gap. Okay, this is the conduction band completely empty, completely filled is the valence band. Okay, तापरे आकु देखिबा at room temperature the valence electron do not have much energy to jump from valence to conduction band, so they do not conduct electricity. Remember, electricity conduct करिया पे निहाती भाबरे electron को valence रू conduction band को जीवा को पड़िबो, because we know that electron is a charge particle, एटा flow हेले ही electrical current आमे पाइबा. Okay, therefore they have very high resistivity of the order of 10 to the power 9 ohms centimeter. Now at very high temperature, यदि बहुत temperature हमें बढ़े देला or under very high electric field, some electrons may move from valence to conduction band, hence insulator may show some conductivity under above condition. Okay, example यदि हमें देखिबा like your glass, diamond, etc. Specially যদি ଆମେ diamond ଦେଖିବା is a material whose covalent bond, ଆମେ ଜାଣିଛୁ diamond ହେଉଛି ଗୋଟେ covalent bond କରିଥିବା ଗୋଟେ solid. Okay, it is very strong in nature, so it has covalent bond and it splits the 2s and 2p levels into two band which are separated by an energy gap of around 6 electron volt, with the valence electrons filling the lower band, and the diamond is said to be an insulator. तापरे next category है conductor. Conductor माने these are the materials in which the conduction and valence band overlap with each other. Okay, that means alternatively यदि हमें कहिबा, we can say that there is no energy gap or forbidden gap between the valence and conduction band. You can see this is the conduction band and this is the valence band overlapping एई जो region रे आछि, right? एटा होछि गोटे conductor रो example. So conductors have very large number of free electrons for electrical conduction purpose. Okay, there is a single energy band which is called conduction band, and this is partially filled at any temperature. Now, as there is no energy gap, that means there is no structure to establish the hole. Hole mane kono? It is nothing but the absence of electron. Okay, suppose electron te valence band to conduction band ku gala, then it will leave behind a vacant space having the same characteristics of that of your electron, but only difference है charge ହେବ ତାର positive hole ର. Okay, so when a small potential difference is applied across a conductor, the free electrons constitute the electrical current. Okay, ତେଣୁ କରି generally conductor best example है metal which works at a very good conduction rate. Okay, so metals like your copper, aluminum, these are the examples of conductors. Now on the application of external field in any form, suppose for example electrical ହେଇଗଲା କିମ୍ବା heat ହେଇଗଲା etc. So the electron shifts from valence to conduction band. So these type of solids are called as your conductors, and even if there is a small energy gap, then the material such as lithium, sodium, potassium etc. exhibits conductivity যদি भी ଗୋଟେ छोटो energy gap भी ନେଇଗଲା ଆମେ. Okay, and in the case of materials such as your barium, cadmium, then zinc, the valence band is completely filled and the empty conduction band overlaps. Okay, valence band ଟା completely filled ଅଛି, conduction band empty ଅଛି, but however they overlap. Okay, so therefore the electrons freely move inside the crystal lattice and cause the conduction. Okay, so next category ହଉଛି semiconductor ର. ତେବେ ତା ପୂର୍ବରୁ କହି ରଖୁଛି ଏଇ ଯୋଉ ଲାଷ୍ଟ category ଆମେ ଦେଖିଲା, okay, ଏଟା ହଉଛି ଗୋଟେ special category. Okay, ଯୋଉଟା କି ଏଠି ତମେ figure ରେ ଦେଖିବାକୁ ପାଉଛ. ଦେଖ, this one where the gap is very small between the valence and conduction band. Okay, ୟାକୁ ଆମେ ଗୋଟେ semi metal ମଧ୍ୟ କହିପାରିବା. Okay, ତା ବିଷୟକୁ ଆମେ ଆସିବା. ତେବେ ଏବେ third category କୁ ଆସିବା, the semiconductor. This is very important. The material in which the conduction band and valence band are separated by a very small energy gap. ଆଉ ୟାର ଅର୍ଡ଼ରଟା ହେବ ପାଖାପାଖି 1 electron volt. Silicon ହେଉଛି ଗୋଟେ example ଯେଉଁଥିରେ କି gap ହେଲା 1.1 electron volt. ଆଉ germanium ୟା ପାଇଁ gap ଟା ହେଲା 0.7 electron volt. These are the semiconductors. So here the energy band diagram which is shown in the figure, and the valence band is almost filled while the conduction band is almost empty, and the semiconductor behaves actually as an insulator at 0 Kelvin, because 0 Kelvin re no electrons will be available free for the conduction purpose in the conduction band. Okay, so this is a very small energy gap between the valence and conduction band in case of semiconductor. Okay, now when the temperature is increased তাহলে ইয়ার characteristic ଏବେ change ହେବ. Then what happen? The forbidden gap or the forbidden energy band is now decreased so that some electrons are liberated, free ହେଇଯିବ for conduction purpose in the conduction band. Similarly, a small electric field ଗୋଟେ ଦେଖିଲା ଆମେ heat ଦ୍ୱାରା, second ଏବେ ଦେଖୁଛୁ ଗୋଟେ electric field ଦ୍ୱାରା which is required to push the electrons from valence to conduction band, and the conductivities here are of the order of 10 to the power 2, that is 10 square MHO meter. MHO means ohm inverse. यार example जेमती कहली germanium होची, then silicon. So finally let us see the conclusions. First point, if the valence electrons exactly fill one or more bands leaving the other empty, then the crystal is an insulator. Second, if the bands overlap, then instead of one filled band and the other over it fully empty, then it will give you an insulator, and we can have two partly filled bands giving a metal. तापर थर्ड पॉइंट रे जोटा कि एबे आसीबा सेमी मेटल कथा, if the energy gap is very small, pakapaki 0.025 electron volt, this is a very small value at room temperature, then the electrons can rise from valence to conduction band on application of field, and the band overlap with some gap as shown in the third figure. So crystals such as your bismuth, these are actually called as the semi metals, are the examples of semi metals. ଆଉ जो last category एटा जो overlapping ହେଇଛି, this is the case of your conductor or metals. Okay, तापरे आकु बढ़िबा. Now let us see the concept of hole. देखो, concept of effective mass has a physical significance. Okay, आमे देखिला जे beyond the inflection points the effective mass m star, okay, एटा आउट बही रु नेछि. Okay, फर्स्ट बही रे याको m effective एई भलिया लेखुतिला. Okay, so effective mass m star becomes negative, okay, beyond the inflection point. Now this is the region close to the top of the band, and in this region the velocity of electron decreases, that is the acceleration is negative. Okay, so এটা হচ্ছে ଆମର जो फर्स्ट लाइन जोनटा प्लस और माइनस पाई बाय ए भितर. ओके, এই ভলিয়া ଆମେ प्लॉट देखिବାକୁ पाउछु v ର. ओके, variation of v with k. Okay, so this means in this region of k space the lattice exerts a large retarding force. Okay, ଗୋଟେ force जोटा कि retarding करूची on the electron which overcomes the applied force. Therefore, in the upper half of the band, the electrons behave as a positively charged particle जोटा कहूଥିଲି, and this is called as the hole, the absence of electron. Okay, so the concept of hole provides a satisfactory description for the charge carriers in the crystal. Okay, so p type n type এই ভলিয়া semiconductor ଅଛି, charge carriers ଜାଣିକି ସେଟା ଆକୁ ଆମେ later on ପୁଣି ପଢିବା. So finally let us compare between the three categories, that is your conductor, insulator and semiconductor. एटा exam रे बहुत पढ़ी थाए. So compare करिबा by taking some parameters. First यदि देखिबा conductivity, ताले conductor रे very high रहउची, insulator रे very low रहउची, semiconductor moderate रहिबो. तापरे resistivity ठीक उल्टा ही जिवो एबे, एठी very low then very high, एठी again moderate. तापरे forbidden gap, conductor रे किछि भी gap नहीं, insulator रे greater than 3 electron volt means large gap. तापरे semiconductor रे medium which is 1 to 2 electron volt. तापरे temperature coefficient of resistance, conductor pai positive, insulator pai negative, semiconductor pai also negative. Then coming to the fifth one, the number of electrons which are available for conduction, conductor is very large, insulator very small, or semiconductor is moderate. Then sixth point, conductivity at room temperature, conductor very good, insulator poor, semiconductor moderate. Okay, then seventh point रे example किछरा हमें जदि दबा conductor पाई हला aluminum copper, generally एटा होची metal. तापरे semiconductor जदि दउछु, sorry insulator जदि दउछु ताले paper, mica, glass. Okay, ଆଉ semiconductor जे हमें जानिला silicon, germanium etc. And at the last point application जदि देखुछु as conductors, wires, bus, bars. Okay, so conduction purpose पाई हमें याको यूज करि परिबा इलेक्ट्रिकल कंडक्शन. तापरे इंसुलेटर को हमें कैपेसिटर रे यूज करू थाउ, इंसुलेशन ऑफ वायर्स. ओके, तापरे सेमीकंडक्टर डिवाइसेस रे हमें जनरली सेमीकंडक्टर को यूज करू. ओके, रिमेंबर सेमीकंडक्टर जनरली रूम टेम्परेचर रे हमें जदि देखिबा इट बिहेव्स एज एन इंसुलेटर. ओके, जदि हमें टेम्परेचर बढ़ाउछु कि बाहर किसी इलेक्ट्रिक फील्ड दउछु ताहले ही जाय कि ये तार कंडक्शन प्रॉपर्टी शो करूची. ओके, यार बेसिक आमे देखिला मटेरियल रो कैरेक्टराइजेशन विषय रे तीनटा कैटेगरी. आकु आमे ई सेमीकंडक्टर रो फर्दर क्लासिफिकेशन, दैट इज योर p टाइप, n टाइप ता विषय रे पढिबा. ओके,
थैंक यू.